Hey everybody, today I'm going to do another differential equations. This time we're doing exact differential equations, which is an exercise 2.4 in this book, right? So it's number one. We're doing number one in this book. Is called a first course in differential equations with modeling applications, right? So we're doing this problem, and this is the problem number one on 2.4, and the problem is 2x minus 1 dx plus 3y plus 7 dy is equal to 0. Again, 2x minus 1 dx plus 3y plus 7 dy equals 0, right? So, and this is the formula that we're using. We're using these two formulas right here. We're using that the partial of m with respect to y should be equal to partial n with respect to x, right? So, this is to check if we have exact differential equation, and this is the format that the equation should be. Should be the m of x comma y dx plus n of x comma y dy equals 0. And we have it right here. We have m and we have x, right? So we have these two pieces which represent this m and this is n, right? So first we are going to do the partial derivative with respect to m, right? With respect to m, partial with respect to m, but actually we do it with respect to y because we do it the opposite. If we have the m, we have the dx right here, we're doing the partial derivative with respect to y. So we're doing the partial derivative of m with respect to y, right? Partial y. In this case, it's going to be, you take the partial derivative with respect to y in this one, so we have no y, right? So everything goes to 0. You treat this whole piece as a constant. So everything goes to 0, so the partial derivative with respect to y in this piece right here is 0. Now, in this piece right here, right, we're doing the partial derivative of n with respect to the partial derivative with respect to x, right? So in this case, we're doing the partial derivative with respect to x. So we don't have no x, right? We have a 3y plus 7, and of course the partial derivative of this with respect to x is 0, right? So now we see that they are both equal. They both equal 0, so that means that this formula over here checks, right? So now I'm going to pick one of them and integrate. I'm going to integrate one of them. The most important thing right here is that I have to fix one. Once I fix that one, I have to stay with that one all the way through. All right, so I'm going to pick m. I'm going to integrate m. All right, so if I integrate m dx, right? If I integrate m dx, right? So well, m is this should be 2x plus 1, right? dx, right? So if I integrate this piece right here, what do I get? I get 2x squared over 2, right? And then plus x, right? So this right here, okay, is equal to x squared minus x, right? we don't care about the constant right now. We don't worry about that because we are going to do a different, little bit different right here. So if I integrate right here with respect to, I am not gonna get a plus c. What I'm going to get right here is another function, right, which is going to be a function of g of y, right? See, I didn't get a c anymore. I didn't get a constant of c. By integrating this, I got another function of y, right? So now I take this piece right here, this integral with respect to m, and gave me the other function of y, and I'm going to take the partial derivative, okay? If I take the partial derivative with respect to y right here, what do I get? This whole piece right here go to 0, and I get g prime of y, right? Okay, so this piece right here go to 0, so I get g prime of y if I take the partial derivative with respect to y, right? Now I'm going to set this equal to this partial derivative right here, okay? I'm going to set it equal to n, okay? I'm going to set it equal to n, right? So what I'm going to do is I'm going to say, okay, g prime of y is equal to n, okay, which is 3y plus 7, right? dy, right? Okay, now I can actually integrate on both sides, right? So when I integrate on both sides, in this case, I get g of y is equal to 3y squared over 2, okay? Sorry, it doesn't look like a 2, okay? So plus 7y, right? Now, okay, I got this piece right here, okay? Now, what did I have in the integration before? I had x squared minus x plus g of y equals 0. Right? Now I know that g of y is equal to this, right? It's equal to 3y squared over 2 plus 7y. So the final answer is going to be this piece right here plus the g of y, which I found, right? Which I have found right here, which is going to be x squared minus x plus this piece right here, which is 3y squared over 2 plus 7y equal, you can set it equal a constant. Okay, so equals z. Okay, that is the answer for that question, and I hope this helps. I only have 9 minutes, so I didn't probably didn't explain it so good. But the most important right here is the process when you fix m. All right, just stick with m all the way through until you get your answer. Alright, thank you for watching, and I hope this helps anybody who is taking differential equations.